Hello everyone and welcome to this tutorial. In today's tutorial, we're going to explore generative AI, one of the most powerful and transformative technologies shaping the future of software, creativity, and business. By the end of this video, you'll understand what generative AI is, how it works, where it's being used, and why it's becoming such a critical skill. So, let's get started. What is generative AI? Artificial intelligence is transforming the modern era by enabling machines to learn, reason, and automate tasks, reshaping how we work, communicate, and innovate across every industry. Artificial intelligence covers machine learning, deep learning, NLP, computer vision, robotics, human AI interaction, expert systems, generative AI, and many more fields. Generative AI plays a vital role in the modern era by enabling rapid content creation, efficient development, intelligent systems, and helping to solve complex problems faster. At this point, you might ask an important question: what exactly is generative artificial intelligence, and how does it create new content from data? The term generative refers to an AI can produce original content, data, or media by learning patterns from examples rather than only analyzing inputs fully. This content can be text, images, audio, video, software code, and even complex three-dimensional designs created by intelligent systems. Generative AI marks a major shift in artificial intelligence as it empowers machines to create content instead of only analyzing data creatively now. By learning patterns and creating original content, generative AI transforms human interaction with technology, making systems creative and intuitive. This capability positions generative AI as a core pillar of modern AI systems, empowering models to create, adapt, and innovate across applications. How generative AI works? Generative AI transforms human input into meaningful output through a structured, multi-step process. From prompt entry to final response, each stage plays a critical role in content generation. Prompt input: user enters a prompt, which is tokenized into numerical representations, so the AI model can understand language structure and intent clearly. Neural processing: the system sends these tokens into a trained neural network that has learned patterns, relationships, and context from massive datasets. Attention analysis: model analyzes the prompt using attention mechanisms to determine which words and concepts are most important for generating a response. Token prediction: based on learned probabilities, the model predicts the most likely next token step by step while maintaining coherence and contextual relevance. Sequence generation: each predicted token is feedback into the model repeatedly until a complete sequence or response is fully generated successfully. Safety control: during generation, safety rules, constraints, and decoding strategies guide the output to remain useful, accurate, and appropriate. Output conversion: the generated tokens are converted back into human-readable text, images, audio, or code depending on the model type used. Post-processing: post-processing steps refine formatting, remove inconsistencies, and ensure the output aligns with expected quality standards. Response delivery: the system delivers the final generated output to the user through an interface such as chat, API, or application layer. Continuous learning: feedback from users and evaluations helps improve future model behavior through fine-tuning and continuous optimization cycles. This process allows generative AI systems to appear creative, intelligent, and context-aware. Types of generative AI models. Generative AI models come in various forms, each designed to create new content by learning patterns from data. Understanding these model types helps explain how modern AI generates text, images, audio, and more. autoregressive models generate content sequentially by predicting the next token from previous ones, enabling coherent text, code, or sequence creation. Transformer models use attention mechanisms to capture long-range dependencies, making them highly effective for language, vision, and multimodal generation. Diffusion models create data by gradually removing noise from random samples, producing high-quality images, audio, and video outputs. GAN models consist of generator and discriminator networks competing to produce realistic data that closely matches training distributions. Variational autoencoders learn latent representations of data and generate new samples by sampling and decoding from probabilistic spaces. Flow-based models generate data through reversible transformations, allowing exact likelihood estimation and controlled high-quality sample generation. Energy-based models define probability landscapes over data and generate outputs by finding low-energy configurations matching learned patterns. Neural language models specialize in generating human-like text by learning grammar, semantics, and context from massive text corpora. Multimodal models generate outputs across text, images, audio, and video by learning shared representations between multiple data types. Foundation models are large-scale pre-trained generative models adaptable to many tasks through fine-tuning or prompt-based conditioning. Each type is designed for specific tasks, but many modern systems combine these capabilities into a single intelligent workflow. Together, these generative model types form the foundation of today's AI systems. Generative AI versus traditional AI. Traditional AI focuses on analyzing data and making decisions, such as predicting outcomes or classifying images. Traditional AI refers to rule-based or statistical systems designed to solve specific tasks using predefined logic and structured training data only. It works by processing input data through fixed algorithms that follow human-defined rules to make deterministic decisions. So, by processes data in structured formats using feature engineering and mathematical models rather than learning representations from data-only rules. Output in traditional AI is generated by applying predefined rules or thresholds that map inputs directly to expected results only for known cases. Okay? Traditional AI systems perform well for narrow problems but fail to adapt or create new content from massive datasets without learning patterns. So, generative AI goes a step further by producing new data. Instead of just recognizing patterns, it uses those patterns to create meaningful outputs. Generative AI overcomes traditional AI limits by learning data distributions, enabling creation of new content instead of fixed rule-based outputs now. Instead of relying on handcrafted rules, generative AI uses deep neural networks to model complex patterns and generate scalable content. Generative AI improves output quality by understanding context, semantics, and structure, producing human-like text, images, or code at scale. By training on massive datasets, generative AI generalizes knowledge and adapts to unseen inputs better than traditional AI systems. This shift allows generative AI to continuously create diverse, flexible, and high-quality content where traditional AI fails completely. This shift from analysis to creation is what makes generative AI so powerful and so disruptive. Generative AI brings powerful content creation capabilities, but it also introduces important challenges and responsibilities. Addressing these areas ensures AI systems remain ethical, safe, and trustworthy. That's why responsible development, careful evaluation, and human oversight are essential when building or deploying generative AI systems. That brings us to the end of the basic introduction about generative AI. If you found this video helpful, please like, comment, and share it with your community. Thanks for watching, and I'll see you in the next tutorial.